Hey guys, Mr. Pusky here. Hope you're having a good day so far. We're continuing our lessons for Chapter 10. We are in 10.4 of Geometry. Let's read the name of the lesson. Ready? 1, 2, 3. Use inscribed angles and polygons. Essential question 1, 2, 3. How do we use inscribed angles of circles and polygons? So inscribed angles and polygons basically means that those angles and polygons are on the circle, and there's certain relationships between the arcs and the angle measures that are land on a circle, basically. Okay, so let's go ahead and get into these definitions here. So a inscribed angle is an angle whose vertex is on a circle is what? Is on a circle and whose sides contain chords of a circle. All right. Basically, an inscribed angle would be something like this. Let's use a different color. So if I drew that's not what I wanted. So if I drew an angle like this right here, A would be an inscribed angle where the vertex is on the circle, and then the sides contain, these are chords of the circle, basically. Okay? Basically an angle that's on the circle, though. It's not too complicated. An intercepted arc is an arc that lies in the interior, in the what? Interior of an inscribed angle and has endpoints on the circle. So again, if we zoom in over here a little bit, so the intercepted arc is going to be the arc that intercepts the angle at the end, like right where the ends of the angle meet the circle, basically, right here, okay? So you can see the angle ends right here and here, and so this whole arc right here is going to be the intercepted arc. An inscribed polygon is a polygon where all of its vertices, all of its what? Vertices lie on a circle. So an inscribed polygon is a little bit harder to draw. Let's see if we can do it here. So inscribed polygon is going to be something like just any kind of polygon whose corners are going to be on the circle like that. That's an inscribed polygon. Okay? And a circumscribed circle, say circumscribed, a circle that has the vertices of an inscribed polygon has the what? Vertices of an inscribed polygon. So basically any circle that meets a polygon on the outside of the polygon like this whole circle, this entire circle on the outside that meets the corners of the polygon, that's called circumscribed, okay? Where it's like, it fits the polygon perfectly inside the circle. That's what circumscribed means, okay? All right, sounds good. So we have the measure of an inscribed angle theorem. So we're going to fill in this blank here, and then we're going to go ahead and do a little bit easier example, okay? So basically what you need to know about inscribed angles, which is the angles that meet on a circle like this, okay? The angle is going to be half, so this is x and this is y. Basically measure of angle ADB, we're going to fill in the blank there, is half of measure of angle of arc AB, like this. But an easier way to think about this is that the angle equals half the arc. Oops, that's not what I wanted. Half the arc, or the arc over 2. And the arc equals 2 times the angle, double the angle. Or what you can say with this drawing over here is that x equals y over 2, or 1/2 y. And y is going to equal 2 times x. So I would probably box this over here, make it nice, and that's a circle. Hey, that kind of works. We'll leave that. Oh, now I goofed it up. Okay, so this is the shortcut. So basically, if you have an angle that inside that's inscribed on a circle like this, means it lands on the circle. The angle is going to be half of its arc, the big arc on the outside here, and this arc is going to be double this angle. It's kind of back and forth. It goes both directions. Okay. So we're looking for measure of angle S. Use inscribed angles. All right. Well, let's use a new fun color here. So we're looking for measure of angle S, which is right here. This angle. Okay. Well, all we know this 37 over here is probably not going to help us because that's for this arc over here. But what do we know about So this is 60 over here, right? So what do you guys think? Is angle S going to be half or double of 60? Hopefully you said half. And what is half of 60? It is 30. So we're going to have, so basically what it's going to be 60 over 2, which equals 30 degrees. So measure of angle S is going to equal, that's a 2, 30 degrees. All right. Easy as that. This angle is half of this arc. This arc is double this angle. All right, sounds good. So now we're looking for measure of arc RQ. Measure of arc RQ. So we're looking for R. Oh, this one's a little tricky, okay? So we're looking for RQ, but they gave us this 37 right here, right? Okay, this 37, we're looking at this angle right here, right? We only have this arc that it intercepts. So what's the relationship between QS and the 37 degrees? Is QS going to be double or half of arc of that 37 degrees? The arc, if you recall, is going to be double. This is going to be double this 37. So what we're going to do is we're going to do measure of QS. We have to find QS first because we can't really work with that other angle. It's going to equal double 37, which equals 74 degrees. Okay, so this is 74 degrees right over here. And now I'm going to erase some stuff so you guys can see it a little bit better. This is 74 degrees. Now, what can you tell me about this shape right here? What is that? What kind of shape is that? That's a semicircle. And how much is a semicircle? How many degrees does a semicircle add up to? It adds up to 180. So we can say we have RQ. We have this is X and this is Y. This is X plus Y is going to equal 180. Or the shortcut is going to be measure of RQ. It's going to equal, what's the shortcut? Instead of doing X plus Y equals 180, we can do 180 minus this one over here, which is 74. There's only two arcs, and one of the arcs is 74. The other one's going to be 180 minus 74, which equals 106 degrees. Okay? So the arc, sometimes you have to kind of like walk your way across the diagram a little bit. So we kind of had to go, we couldn't really do anything with this arc right up here yet because there's not really like an angle that like intercepted it nicely. So what we had to do is we had to figure out like sometimes using semicircles is a really good trick to figure out other missing angles in arcs basically, okay? All right, sounds good. Example 2 is a little clunky, but we'll go through it a little bit here, I guess. So, I think we're gonna skip this explanation here because I don't know. Let's go through it. Why not? So we have we're looking for, it says what's the relationship between angle HGJ and HFJ? Okay. Well, if this is 39 degrees right here, it looks like it's in this circle right here, this angle right here. What can we say about this arc? If that angle is 39 degrees, is HJ going to be double or half of 39? The arc is double the angle, so we're going to do that's going to be 78. You can kind of tell this arc is a little bit bigger than the angle, don't you think? Doesn't it look like it's a little bit bigger than the angle? Hopefully that makes sense. This is going to be 78 degrees, and now we can walk our way across the diagram a little bit. So now we can look at this angle, which is what we're trying to find. That was really sloppy, but we'll go with it. That angle, now you notice what this angle, if this is angle X right here, we have angle X, and we have this 78 degrees. Well, what is X in relation to 78 degrees? X is going to be double or half of 78. The angle is half the arc, so it's going to be 78 over 2, which equals what? It equals 39 degrees. So this is also 39 degrees. So what this is trying to get across here is basically, if you have two angles, let's use a different color. If you have two angles like this that both intercept this same arc, that both intercept this arc right here, they're going to be the same. So we have X and Y. If they both intercept the same arc, they both meet. Oh, I kind of goofed that up a little bit, but this should have been blue over here. Let's fix that. Dang it. Just goofing up my life, guys. Should have been like that. If you have x and y, they both intercept the same arc, they're going to be congruent. Just like over here, this is 39, this is also 39. Okay, if they both intercept the same arc, which is 78 degrees, they're going to be congruent. So down here, we're going to put measure of arc. ADB is going to be congruent to measure of arc, or angle, sorry, angle ACB. Okay, so these angles, this is x and y. If they both meet the same arc like this, they're going to be congruent. X equals y. Okay? All right, moving on. It says name two congruent figures in the figure. Two congruent angles in the figure. All right, well, let's highlight this arc first. So we have this arc right here. Okay? And we have, I'm going to highlight a couple angles here, right here. So there's one angle. Can you guys name the other angle that's going to be congruent to angle SPR? Hopefully you said like RQS or something like that. If we go like this, do you see how both these angles, angle 1 and 2, are both going to intercept this arc? So we can say that angle 1 is congruent to angle 2. And also, if we go the opposite direction, I'm going to erase this too so we can... I'm going to erase this stuff right here. Also, if we go the other direction, we go like this, and we have this arc right here, and we have this. We can also say that 3 and 4 are going to be congruent. Angle 3 is congruent to angle 4. Okay? Because they both intercept this arc right here. All right, hopefully that's making sense. I'm trying to look at my drawings here to make sure that it looks, hopefully, relatively neat enough so you guys can follow it along, you know, when you're doing the other stuff here. Why don't you guys go ahead and try these checkpoints, pause the video, try these checkpoints on your own, see if you can figure them out, okay? And then we'll go ahead and go through them together as a class. Okay, so we're looking for this angle right here. It helps to highlight stuff. I don't know if I picked up on that, guys. We should be trying to highlight stuff to see what stuff happens here. Okay, we're looking for GHJ. We know this arc right here is 100 degrees. So what do you guys think? Is that angle going to be double or half of 100? Hopefully you said half, because angles are half of the arc. So we can go like this. We can say that it's going to be 100 over 2, which equals 50. Or 1/2 of 100 like this. You could do that too. It's going to be 50 degrees. If this was 100 right here, then this would also be 200 if you were going to do it that way. Okay? All right. Now we're looking for measure of arc CD. CD. Okay, so that's this arc right here. So look, we're looking for angles that intercept this arc here. It looks like this 40 degrees right here intercepts this arc. So what do you guys think? Is CD going to be double or half of 40? The arc is double the angle is half the arc, so we're going to do 2 times 40, which equals what? 80 degrees. All right, and then checkpoint number 3, find measure of angle RTS. RTS we're looking for. Well, they only gave us, we'll start with what we know. We have this 31 degrees right here, and that is this arc right here. That is this. Can you guys see another angle that intercepts that blue arc? Yeah, we can also go like this. That was a little embarrassing. Yep, so that one, if RQS is 31 degrees, what is this one also going to be if it intercepts the same arc? It's going to also be 31. You could also double it and go like this. This is 62, and then go back. This is going to be 31. 31 degrees. So this is going to be 31 degrees. But if you see it right away that those both intercept the same arc, you don't need to do any math. You can just go ahead and put 31 degrees. All right, last couple things here, actually. All right. Okay. So, theorem 10.9. So, a couple theorems here. If right triangle is inscribed on a circle, then the hypotenuse is the diameter of the circle. And also the converse is also true, so we're going to put AC right here. Okay. And then also, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Supplementary means they add up to how many degrees? 180 degrees. Okay, so basically, if you have a right triangle, on a circle like this, inscribed like that, it's gotta be the hypotenuse is on the diameter, and then also these angles that I'm highlighting right now are going to be supplementary, the opposite angles. Okay, let's go ahead and do this last couple examples here. So, example A, so it looks like we have a quadrilateral that's inscribed on a circle, which means that these opposite angles are going to be congruent, or not congruent, supplementary, my bad. So, what are we going to do with 100 and y if they're supplementary? Yeah, we're going to do y plus 100 equals 180. Then how do we solve for y? Minus 100. Y is going to equal 80 degrees. And then, what about these next two right here? These are also going to be congruent because they're opposite. So they're not congruent. Sorry, they're supplementary. I keep goofing that up. I hope I'm not messing you guys up too bad here. X plus 88 is going to equal what if they're supplementary? 180 degrees minus 88. And we're going to get, for an answer, X equals 92 degrees. Okay. Why don't you guys try example B on your own? It's going to be kind of the same thing, except now you got variables in both numbers there. Give it a try. All right, so again, we have a quadrilateral that's inscribed on a circle, so these opposite angles are going to be supplementary, not congruent. So 8x plus 4x are going to add up to how many degrees? 180. Okay, so what's 8x plus 4x going to be? 12x. So we divide by 12. X is going to equal 15 degrees. And the last couple, 3y and 3y are going to be supplementary. So 3y plus 3y equals 180. So 6y equals 180. And y divided by 6 is going to equal 30. Okay. I think I even skipped the last couple examples in the notes. So, all right, that's our lesson for today. So, tomorrow, the day you're watching this, should be Thursday. We're probably going to have a mini quiz again on Monday. So be prepared for that. Make sure you turn in your homework the first 2 days if you want feedback. And also, make sure that you turn it in the right format. Make sure it's not rotated sideways. Make sure it's the right face up and stuff. And thank you guys for watching. And you can use this lesson on your quizzes too. So keep that in mind that this will help you for quizzes, okay? Thanks for watching. Have a great day, everybody.